Okay, here we go. All right, so what are we doing? We are going to work with this. Rational expressions. Okay. Pretty much the rest of the year is rational expressions. Here's what you're going to do. You're going to take them, you're going to reduce them, you're going to multiply them, you're going to divide them, and you're going to add, subtract them. And what are they? Rational expressions? They're basically this. Fractions. So what's a rational expression? It's a fraction. Now, you have been dealing with fractions for so long, guys. What if I gave you something like this? What can you do to 8/14? Okay, you gave me the answer, but what did you just do? What? Reduce.
Divide by 2.
You reduce it. Okay, so you got what? 4 7s, okay? All right, but here's the deal. I want you to know what happened. Yes, the answer is 4 7s, but what happened was this. For this to go to that, there has to be some kind of dividing going on. So when you think of the number 8, the number 8 is really just 2 times what? 4, and the number 14 is 2 times 7. Now when I write it like that, you can see the division, right? 2 divided by 2 is what? 1. So really the answer becomes 1 times 4 and 1 times 7, 4 7s. So this is what really happened to get to that point. And this is what you're doing today. But you're not going to get the numbers. You're going to get algebraic expressions. Okay? For example, let me throw one at you. Let's go this one over, let's go this one. Okay? 14x cubed divided by 6x. Look at the numbers. Tell me the answer. Just the numbers.
7.
Okay, it's 7 because 2 goes in there. 2 goes in here. 3. 7/3 is the answer. Tell me something about the variables, x over x.
Yeah, you cancel out.
Yeah, you can do something. Remember our exponent rules? X to the third over x to the first. What's the rule? Subtract. Yeah. 3 minus 1. X what? Where? Top, bottom? Top. Okay. This becomes the answer today on your assignment right there. And I got to show you something. Oh, by the way, if you want to copy this stuff down, that's fine. But really right now, all I want you to do is listen to this. This is called, just so you know this, it's called a monomial. Okay? This down here is called a monomial. Now you can only cancel monomials with monomials. Does that make sense? Why is this called a monomial?
Because there's only one term.
Okay, there's only one term, but one term.
It's not separated by addition or subtraction.
That's perfect. Thank you. Because to have a binomial, you'd have to have a plus or a minus sign. That's why you only have one term. Some people get confused. They think this is 2 terms. 14 is a term. X cubed is a term. It's not. Got to have a plus and a minus in the middle. So this is the only thing you can do today is take a monomial and divide by a monomial, or a binomial with a binomial. Now that's when things get tough. Here we go. What about binomial with binomial? Okay. You've learned some of this, yes. Not all of it. Okay, ready? X plus 6 over x plus 6. This is a binomial over a binomial. What do you think? 1. It's the same number, isn't it? Yeah, if I put a 2 in here, what would it say?
8 over 8.
8 over 8. It's definitely 1. You will do this today. You'll cancel, and put 1 over 1, correct?
Yes.
Okay, what would you do with this one? That's a binomial over a binomial. What are we going to do?
Divide by 6.
Divide by 6.
No, it's the top.
Okay, you're taking the top, divide by the bottom. What are you saying there? That's not right, quite right. What?
Divide 3x. Or you subtract 3x minus x, 2x.
Okay,
Or
you
I
guys,
don't know.
hey, you guys, it's like you forgot what I told you. Look, 6/8. 6/8 is really 2 times 3 over 2 times 4. The answer is 3/4. See what I did? Oh, right, someone, right there, by my phone. Oh, sorry, on the wall.
Oh,
Yep.
that's all.
Okay, see this? Guys, can you turn, I turned 6/8 into multiplication. Can you turn that into multiplication?
Yes.
You should say yes, because I can,
Where'd you get your 8 from?
I can what? Factor, right? Where I what?
Where'd you get the 8 from? 6 over 8.
That was just a random.
I said, you guys
Oh.
forgot what I did. I said, anytime you have a fraction, you can make it multiply over multiply, cancel what you see, and the answer's 3/4. Guys, factor that top for me. What would you get? Right?
About 3 times x.
GCF. What's the GCF on top?
3.
3. They have 3 in common. Take out a 3 times what?
X plus 6.
Yes. So really, this number that you're looking at is just 3 times x plus 6. Divided by what? X plus 6. Now what do you think?
Cancel.
Yeah, this number and this number can cancel, just like the 2's did here. So then your answer becomes what? 3. 3 over 1, which is basically 3. So today when you look at your problems, you will factor everything you see. You'll factor, and then you'll look for something to cancel. And the only thing you can cancel is x plus 6 with an x plus 6, x minus 2 with an x minus 2. Okay? Now, hang on. There is a small trick here, and that's this. What about this one? Tell me the answer.
Still 1.
Okay, they're the same number. 1, 1, the answer is 1. Okay, tell me the answer to this one. What?
1.
Still 1. I switched them around on you, but it's the same number anyways, right? It's still 1. Okay, what's the answer to this one?
19.
1.
Negative.
Negative
1?
Negative
No, it's 1.
1. With
Negative.
negative 1.
Okay. Pick a number for C, guys. Pick a number. 2, I heard 2. Put a 2 in for C. Put a 2 in for C. What's 2 minus 3? Negative 1. What's 3 minus 2? What's the answer? Negative 1. It looked like I could cancel them out and just put 1 over 1, but they're not the same. They're actually opposites. They're opposites. So here's how you tell they're opposites, though. Watch this. If you want to know, are they opposites? You look at the signs. This is positive C. What's this? Negative C. This is negative 3. This is positive 3. If every term is opposite, top and bottom, you have opposites. I would just cancel it out like this, and I'd put 1 and negative 1. That's what I would do. So when you do your assignment, you see opposites, it's negative 1 over 1, not 1 over 1. Okay? Is that good? Here's a
So does it always, if there's an equation like that, does it always equals -1?
yes, yes. I mean, I'm just trying to say, when you see opposites, cancel them out. Put negative 1 over 1. Okay, here's a problem that many students have, though. What's the answer?
It's 0. X equals 0.
I'm not solving. I'm just saying, reduce that fraction for me.
1 over X.
1 over x. Okay, because you're saying 5 goes into 5 once, 5 goes into 5 once, so the answer is 1 over x, right?
Can't be done, it's a monomial and a binomial.
Yep, that's exactly what I said the very second class started. You can't touch what?
This.
A monomial with a what? You can't do it. Guys, that's a trick. I knew somebody would say 5, 5, 5, cancel. It's a trick. Don't do it. Monomials and binomials, do not touch them, or else you get it wrong. Okay? All right. Can we move on now? Here we go. You didn't say anything, so I said let's move on. All right. You can read that if you want. I'm just going to get started. Here we go. These are just fractions. There's nothing to do except what? Simplify. What that means is reduce your fractions. Okay. Here we go. Look at the number, 24 over negative 6 right now. What do you see they have in common?
6.
6. Okay. So 6 goes into 6 how many times? Once. 6 goes into 24. 4. So I'm going to call my answer right now 4 over -1. Right? What about the x's over the x's? Can I do something? Yeah. What's it going to be?
X on top.
X on the top. Y's. Y on the bottom. Exactly. The y's cancel. 3 minus the 2 on the top equals y. This becomes your answer, correct? There's nothing to do now, right? I got x's over y's, I can't do it. I got 4 over, what's this number? 1, can't do it. Can I tell you, a lot of students they always ask me, can I put the negative on the bottom, on the top? Sure. You could have wrote it like this, right? Isn't that the same thing? Isn't this also the same thing? As long as you have a negative sign somewhere, it's negative. Okay, I don't care if it's on bottom, top, or even with the bar. Okay? Good? Monomial, pretty easy. Here we go. Now the binomials show up. You can't cancel unless they're dead on the same thing. Does this look identical to this? No. Factor. Then cancel. Go. You don't get much time. The top was factorable. How, John?
I don't know.
Elizabeth.
The greatest common factor is 4.
Okay, greatest common factor is 4. Take it out. What's left, Elizabeth?
3 minus x.
3 minus x. She got it. Good job. Taylor, the bottom's factorable. How do I do it?
I haven't even started.
Okay, Faith. How do you factor the bottom?
X minus
X minus 3 times x plus 3. If you don't remember, we called this the difference of 2 perfect squares. These are all over the place in your lesson today. Look for these difference of 2 perfect squares. It's your best friend. It's factorable in 5 seconds. Okay, look at what you have. Do you have any binomials that look identical? 3 minus x, I don't see 3 minus x. They're not identical. How about opposite?
Yes.
This is the opposite of which one?
X minus 3.
Okay, check it out. This is 3, this is negative 3. This is negative x, this is positive x. They are opposites. Put what? I always go like that. I put the negative on top. And this is a monomial. This is a binomial. Don't touch it. So this is the answer, guys. You ready? On the top, it's 4 times negative 1. On the bottom, I just have what?
X plus 3.
X plus 3. That's it. A monomial and a binomial cannot even be talked about. Can't even touch it. Yes,
Can I use the bathroom?
yeah, go ahead. Okay. Bottom left, go. Factor and cancel. Go. Remember, trinomials factor into what? Binomials, right? Colton, do you know the factors at the top?
No.
No? Okay. Molly?
X plus 4 and then x minus 2.
X plus 4, x minus 2. How do I check this? I just multiply the number 4 and negative 2 to get negative 8. It works. Then I add 4 to negative 2 to get 2. It works. She factored it correctly. This is back in November when we started factoring, guys. We factored for over a month. The bottom. Maddie, do you have it? No. Aaron, do you have it?
X minus 3 and X minus 2.
X minus 3, X minus 2 is negative 3 times negative 2, 6. Yes. Is negative 3 plus negative 2, negative 5? Yes. He did it right. Now you divide. Well, division, if you see multiplication, you cancel whatever you want to cancel. It's got to be identical or off.
X minus 2 and X minus 2.
Yeah, it's pretty obvious, right? 1, 1. Can you cancel these? Are these the same? Nope. Are they opposites? Nope. You're done. The answer is x plus 4 over what?
X minus 3.
There you go. You cannot reduce that fraction. Okay. Okay. Next. Go.
Are we doing the whole?
No, we're not doing the whole packet. I have to do this whole first page though. You guys need practice. We're gonna do probably about 5 more after this. And there's like 8 more to do. Will, do you have the top?
X plus 5 and X plus 2.
Okay, x plus 5, x plus 2 is 5 times 2, 10. Yes. Is 5 plus 2, 7. Yes. Adrian, do you have the bottom?
X minus 5.
Okay.
And X plus 2.
Okay. Is negative 5 times 2 negative 10? Yes. Is negative 5 plus 2 negative 3? Yes. You guys factored perfectly. Are there any factors that look alike?
X plus 2.
X plus 2 out with x plus 2, 1 over 1. Are these the same?
No.
No. Are these opposite?
No.
No. Here's the deal. If you guys ever get confused, just put a number in like, oh, let's just put a 3 in. That would be what?
8.
8 over negative 2. Are they the same? No. Are they opposites? No. So guess what? You can't touch those. They're not the same. They're not opposites. You can't cancel them out. The answer is what? X plus 5 with what? X minus 5. Okay? First page is done. All it was reducing fractions. That's it. Next page, when you flip it, is what? Multiply. Okay? But before I multiply, let's go back to what grade?
Kindergarten.
No, that's too far. How about that grade?
6.
When you did this in 5th grade, right? Your teacher said when multiplying fractions, do what? Common denominators. Only when you add and subtract. No. Cross multiply. Did not tell you that either.
Multiply across.
What?
Multiply across.
Yeah. Guys, your teacher probably said this way, you're done. Answer 2 over what? 15. That's how you multiply fractions. Do you think it changes in 11th or 12th grade? No. So let's just do what we did in 5th grade to our problem, okay? Go back to this one. All right. Take that fraction times that fraction, and you will get on top what?
33.
Oh, yep.
A, B,
A, B, Q, C to the 5th. Over
42.
42,
A,
A,
B to the 4th,
B to the 4th,
C to the 4th.
C to the 4th. Now, why did we go ABC over ABC? Because we just want to see the like bases, okay? All right, let's reduce. What goes into 33 and 42?
3.
3 goes in here 11 times. 3 goes in here 14 times. So this would be 11, this would be 14. Okay. What about A over A? What happens?
Cancel.
Gone. B to the third over B to the fourth.
Subtract.
B on the bottom,
B on the bottom,
C on the top.
C on the top. Now what? I got a monomial over a monomial. Can I do much? No. Yeah, C over B doesn't work. 11 over 14 is already reduced. You're done. That's how you multiply. Okay, I will tell you this really quick. You could have, just so you know, you could have done this right away. You could have said, hey, 3 goes into 3 once, and 3 goes into 21 7 times, and then 1 times 11 is 11, and 2 times 7 is 14. You would have got it quicker. You would have. Okay, now you got binomials times trinomials and all that. So start factoring, and then do what we just did. There's one up there that is not factorable. Which one's not factorable?
X minus 5.
Bottom what?
Left.
Left, yeah. There's no GCF. It's not the difference of two perfect squares. This one, you're just done factoring. You can't factor that. That's a freebie. So upper left, Gavin, what'd you get?
X plus 3, X minus 2.
X plus 3, X minus 2 looks good. Guys, I'm going to speed up now because I have people leaving pretty quick here. Next one, Tiana, what'd you get?
X plus 5, X minus 5.
X plus 5, X minus 5, because it is the difference of two perfect squares. Bottom right, Isaac, what'd you get? Nothing? Anna, what'd you get?
X plus 3.
Okay.
X plus 1.
X plus 3, X minus 1.
Plus 5.
Oh, plus 1, sorry. That times that is 3, that plus that is 4. She got it. Okay, we're done factoring. Now start looking for like factors. See them? What with what?
X minus 5.
Oh, X minus 5 with an X minus 5, 1, 1.
X plus 3.
X plus 3 with an X plus 3, 1, 1. Anything else? No, we're done. So the answer on top, it's that number, X minus 2 times this number, X plus 5, over X plus 1. I am not going to make you FOIL this up. Guys, you've been foiling all year. This is where you get your break. You don't have to FOIL. That's the answer. That is it. Okay? If you can factor, yeah, the canceling's not that hard. Okay, let's just do one of these down here, and I chose this one. Okay, do that one. Who's leaving me in just a few minutes? Okay, I gotta tell you right now. So you do division, you do this thing, you just turn division, you take your divisor and you reciprocate. So then it becomes multiplication all over. Yeah, so what you basically is when you read the 9 squared on top, 8x cubed on the bottom, and then you just do what you did. Yeah, that's really all it is. Okay. Then you're right back to this problem again. just doesn't change. So you like that too. That one again. So you need to use multiplication. Okay. Top. Ready? Annalise, did you get this one?
That's just 2x minus 8.
Okay. Well, you know what? There's something in it.
2 on the
Oh,
outside.
2 is okay, so
Yeah,
it'd
is it
be
G-
x minus 4.
Yep. GCF. Got it. Okay. How about bottom, John?
X plus 4 and X minus 4.
Okay, good. How about upper right, Hannah?
X plus 4, X plus 1.
X plus 4, X plus 1. She's right. Eric, bottom right.
X plus 4, X plus 4.
Good. You guys are good. You guys know how to factor. That's nice. Okay, likeness happens where? Let's just say it.
X plus 4 on the top and X plus 1 on the bottom.
Okay, 1.
X minus 4.
Anything else? Yeah, no?
No.
No, we're done. So it's 2 times this, so I'm just going to write 2 times x plus 1 over x plus 4 times x plus 4. There's a quick way to write it.
1
X plus 4 what?
squared.
Squared. You can just write it like that if you want. Right? Okay, let's be done with multiply. Let's go to division. Okay, turn the page. And before you turn the page, let's do this. 6/7, and let's divide 6/7 by 1/14. Going back again to 5th grade. Your teacher told you what, Adrian?
Flip the second and multiply across.
Flip the second fraction.
Yes,
Okay, so this gets flipped.
yes.
14 over 1. 6 over 7. What am I doing here? Yeah, that's the most important thing. You do not divide fractions. You multiply by the what?
Reciprocal.
Reciprocal. That's how your teacher explained it. And it doesn't change. It doesn't change.
Do you want the test back?
Yeah, just put it right there, will you? Okay, so here we go. Try that one right there. Multiply. Don't divide. Multiply by the reciprocal. Okay.
I get it on the phone.
So this one I did right away. I turned it into multiply, and then I flipped the divisor. I took the reciprocal of the divisor, and now I'm just going to tackle it. So did you guys multiply those numbers and get really big numbers and then reduce? Or did you reduce right away?
I'd reduce it.
Yeah, I would too. I mean, you can get the big numbers and then reduce, but anything you see for numbers, cancel?
16. Wait, no. I'm thinking about
What?
I'm thinking about something else.
Guys, look at the top, look at the bottom numbers. Don't they have something coming?
You just reduce straight up.
Yeah, that's what I'm saying. Right away. Don't wait.
Yeah, baby.
You say what?
Could you do
8x
6?
plus 5. Or do you want to reduce x's too?
I'm not even talking variable. I'm just talking numbers.
Okay.
16,
16 and 8. 8 goes into 8 once. 8 goes in here twice. Right? What else?
3.
3 goes into 3 once. 3 goes in here 3 times. Look at your numbers now. What's the number going to be when it comes up? 2 times 3, 6. 1 times 1, 6 over 1. It's just 6, guys. That's all it is. 6 over 1. Okay, now do the letters, the variables. It's x to the 5th times y to the 2nd. Over y cubed, x cubed. I kind of like to line them up, to be honest. X's over x's and y's over y. Okay, 6 over 1 is done. What about x's?
Subtract 5 times.
X squared on top. What about the y's?
Y on the bottom.
Y on the bottom. You're right. And is there anything else I can do?
That should be good.
That is good, yep. Okay. Those are what I call, I think, the easiest problems for you on the quiz next week. Okay? So just don't make a silly mistake is all I'm going to say. Next, now the binomials come and the trinomials. You have to factor and remember to multiply by the reciprocal. Go. You okay, right? Okay. Anybody struggling now? There is one up here that's not factorable. Anybody know which one it is?
2x minus 1.
2x.
2 minus x.
2 minus x.
2 minus x, yeah. 2 minus x is not factorable. There's no GCF. It's not the difference of two perfect squares. Okay. Upper right, anybody want it? Who wants to say it?
X plus x minus 2
X what?
plus 5 x minus 2.
X plus 5, x minus 2, says Eric. Is he right?
Yes.
Yes, he's right. Okay.
You can flip it, like do the reciprocal.
Oh,
When
look
you
at
do
that. I was just going to tell you, make sure you don't forget to do what?
The reciprocal.
The reciprocal.
You can
Guess,
do that before you.
guess
go.
what I did?
Twice.
I forgot to flip it. Sorry. My fault.
Can you get to
Sometimes.
it?
You're not thinking clearly. Sorry. All right, here we go. So that gets flipped to the bottom. This one goes to the top. So x squared minus 1 becomes what?
X minus 1, x plus 1.
X minus 1 times x plus 1. Okay, there. This one, bottom left. Kind of, yeah.
Oh, x plus 1,
X plus 1.
x plus 1.
Okay. X plus 1 times itself. X plus 1. She's right. Okay. Just don't forget to flip the fraction like I did, okay? So you multiply instead of divide by the reciprocal of the second fraction. Anything look alike?
X minus 1.
X what?
Minus 1 and x plus 1. Can you cancel them?
X minus 1, X plus 1, no.
No. X plus 1, x plus 1.
Yeah, okay, X plus 1, 1, 1. Anything else look alike?
2 minus x, x minus
2 minus X with X minus 2
2.
looks
Oh
like.
shoot, those
What?
are opposites.
Those are opposites because that's a 2, that's a negative 2, that's a negative X, that's a positive X. Go ahead, cancel, but do what?
Negative
1.
Negative 1. Okay. Anything else look alike or opposite? How about X minus 1 with an X plus 1? Are they opposite?
Yeah.
Yes.
Oh yeah.
Guys, that's negative 1, that's positive 1. That's positive X, that's positive X. They're not opposites. Everything's got to be opposite to be opposite. Everything's got to be the same to be the same. They're neither. They're not the same. They're not opposite. Leave them alone. Don't touch them. I think we're done. So here it comes. On the top, what's the answer? Yeah, negative 1 times X minus 1. And on the bottom, you get X plus 1 times what? X plus 5. Got it. Okay. That negative 1, if you guys want to run it through and call it negative X plus 1, I don't care. You don't have to, but whatever. Go to the bottom right, and that's it. We're done. To the bottom right. This one's kind of tough. can factor that. That's the difference of two perfect squares. Not sure why you said x squared times x. Oh, I'm sorry. You didn't take the GCF. There's a GCF in there. That's why this was kind of weird. Okay. There's some GCFs in this one, guys. Be careful. How about the upper left one? What do they have in common?
X's. 3x.
3 and an x. Yes. You guys should take it out of 3x. Times, what would be left if you took out a 3x? 2 minus x is correct. Okay. If you miss that GCF, these get really tough. How about the one on the bottom? 36 minus x squared. Is that the difference of two perfect squares? That's perfect. 6 times 6. That's perfect. X times x. Yeah, you guys, that should be quick and easy. What is it? Here's the problem. You said x first, x first. You have a 36 first. You want 6 times 6 first. Plus x minus x last. So the order does matter, guys. It has to be 6 plus x times 6 minus x. Yes?
Why can't you put a negative in front of it and write it as x plus 6, x minus x? Or
You could. You could. I just don't do that. I'd have to look at what you're doing. I think what you're doing is fine. I just don't know until I look. Okay?
Okay.
All right, guys. See that one? That's kind of weird. What do you think?
Move 1x because everything
Yeah.
has an x.
Everything has an x. The GCF is x. Put it on the bottom. What's left? X squared minus x minus 2. But now look inside. You see a trinomial, don't you? What about the trinomial on the inside? Could it be factored again?
Yeah.
Into what?
2x
X
plus 1 and x minus 2.
Yes, okay. Okay, so now what I did, guys, is I factored out the GCF, then I looked at the trinomial and factored it again. That's what you should have on the bottom. Now, this is probably the easiest one up here, one of the easiest ones. What's this one come on as? Two numbers that multiply give you negative 6, but add up to negative 5.
x minus 1x plus 6.
Ooh, your signs are backwards.
6.
X minus 6, x plus 1. Is it negative 6 times 1, negative 6? Is it negative 6 plus 1, negative 5? Okay. I think you had your signs backwards, Hannah. Okay, here we go, guys. Look for like binomials and opposite. Where do you see anything?
Plus 1.
X plus 1 with an x plus 1. Exactly the same. 1 over 1. 2 minus x with an x minus 2. They're not the same. They're what? They're opposites. Put negative 1 over 1. Anything else?
6 minus x and x minus 6
Are
opposites.
opposites. Yep. So put negative 1. Okay, I'm done. Because x, I'm not done. So you guys see something else?
With your x and the x.
Okay, guys, this is a monomial right here. This is monomial 3x over what? Another monomial x. This is 1x. What do you notice? They both share x. Get rid of this x with this x, and that's gone too. Now, what do you have on top? 3 times negative 1 times negative 1 times positive 1. What's that? 3 over 6 plus x times 1 times 1 times 1 times 1.
6 plus x.
Yeah, 6 plus x. Do you want me to, hey, 3 over 6 is 1/2, right? Should I cancel?
No.
Why not?
Monomial over binomial.
Monomial over binomial. Can't touch it. No. Get it? No? Nancy Hannah.
Hello.
Um,
In a minute.
tomorrow I don't have to teach anything. I got it all, so you can just kind of, you can ask me a lot of questions tomorrow. You're gonna get like another worksheet, but you know what you're doing, or at least like somewhat know what you're doing. Okay? You get it? That's good, because then Friday will be easy for you.
It's Friday.
Test back, yes, I will take this back.
What?
Screen good.
I get tired. Yeah, I'm over mine.
I'll be right with you, Hannah.
I completed this.
What did I miss?
Take this math class and it's not.
Nobody?
Alright, I'll bring it. Yeah, you. I remind myself of good. Just let that already go. I can bring my, I need to bring my electric, or I can bring my acoustic is but I have to mine small, put my amps. So I could leave my power with all the it's my no, my power for my amp is the same. Oh, I see. Also, I've never seen
Said
these
tomorrow. He doesn't.
It's not mine. Well, I just can't see it. Mine's plugged in on the side.
How did you get this computer?
It's what it is real. It's actually
Yeah, I know mine. Just the only thing is the power's in line.
Oh. Yes. You are
Wow, our second was supposed to be mine.
Okay.
That's not the time. That's the question.
Yeah.
Give it back.
36 is first.
Going in reverse, they have better
And I
control.
look for opposites.
Hey, should I bring my amp too? Well, my amp, it's nice, but you probably won't bring your own. Yeah.
All right, I need a test.
That's what it is.
It's up there. That's why they're.
I gotta remind myself.
I need the test. I need the test. Walk on, take my test. Here you go.
You finally, I can finally use my,
Isaac, I don't have time right now. Just talk a little bit. Yeah. Yes.
Yeah.
Test. Test. Put the test up here.
I can put this, it weighs nothing.
Aaron. Yes.
Yeah,
Manny, did I get you?
Yeah, she was.
I'm coming today.
You're talking 3 to 4, right?
Yeah.
Okay. John?
Yeah.
Test?
I was just trying to get a drive home.
Yeah, go to the office. I will be there in 3-4 minutes, okay?
I'm going to tell Miss Kinnan right now.
See you, Molly.